Good morning, students. Once again, I welcome you to my video lectures on signals and systems. I am working out some of problems from Simon Akin's book on Z transforms. Given x of n, given by z square plus 4 with ROC mod z less than 2. Determine x of z for the following. Y of n equal to x of n plus 1 plus x of n minus 1. Now we have to find xz. So to find the xz, first look into this. So first look into this term and you remember the property. The property is shift property. Shift left. That is n plus 1. Shift left. Therefore, z transform is given by z to the power of 1 x of z. X of z. Next, plus x of n minus 1. That is shift to the right. Therefore, z to the power of 1 unit, z to the power of minus 1 x of z. What about ROC of this? ROC is mod z less than 2, mod z less than 2, and one thing, z is in the numerator. It cannot be infinity. So z less than 2 and z not equal to infinity. So z must be less than infinity. Mod z must be less than infinity. Then here the xz ROC mod z. Here there is, sorry, I will rewrite it like this, x dash, because you should not get confused. That is why I will use another notation. Now mod z less than 2 as usual. Then if this z goes to the denominator, it cannot be 0. If it becomes 0, then it becomes infinity. So then there is no convergence. So z greater than, mod z greater than 0. Mod z greater than 0. Mod z greater than 0. Therefore, the answer is answers. You write substitute for z into z by z square plus 4 plus z to the power of minus 1 into z by z square plus 4 equals z square plus 4. Here cancels z minus 1. So z square plus 1. Z square plus 1. This is the answer. And the region of convergence is mod z less than 2. Mod z less than 2. Mod z less than 2. And mod z less than 2. And this is the answer. Next, y of n equal to x of n, convolution x of n. So in this way, it repeats, and totally it repeats m times. So remember convolution property. If you remember convolution property, then y of z equal to m times x of z into x of z, etc. So m times, that is x of z to the power of m. ROC, no change. ROC here, for each and every term it is mod z less than 2. Therefore, ROC mod z less than 2. Next problem. Third problem. I am working out this problem from Simon Akin's. Y of n equal to n minus 3 into x of n minus 2. So you should arrange the terms in such a way that you identify the properties. So n minus 3. Now what I will do is, I will expand n into x of n minus 2 minus 3 x of n minus 2. Then y of z equals this one. The property here is n x of n minus 2. There are two properties here. Shift property here, then after shift property, multiplication by ramp. Multiplication by ramp. Therefore, multiplication by ramp next. So first you do x of n minus 2, that is z to the power of minus 2 into z by z square plus 4. Z to the power of minus 2 into z by z square plus 4. Then ROC mod z less than 2. Mod z less than 2. Next, multiplication by ramp. Multiplication by ramp, that is of n, that is minus z d by dz of minus d by dz of this one. And ROC remains same. ROC remains same for multiplication by ramp. Therefore, mod z less than 2. Next, minus 3. Again, shift property. Z to the power of minus 2 xz. Xz is z by z square plus 4. That's all. And ROC once again, mod z less than 2. And z goes to the denominator and z greater than 0. Z greater than 0. Next is simplification. Minus z. Here z to the power of minus 1. Then z to the power of minus 1. It goes to z to the power of minus 1. Then n x to the power of n minus 1 square into z square plus 4 minus, I am applying u by v formula. First I differentiated. See here z minus 2 into z means z to the power of minus 1. Differentiated first. That is minus z to the power of minus 2 into z square plus 4 minus z square plus 4 is differentiated. That is 2z multiplied with z to the power of minus 1 divided by z square plus 4 whole square. Next minus 3 by z into z square plus 4. And lastly, you have to apply linearity property. Linearity for both terms, z mod z less than 2. Therefore, region of convergence is mod z less than 2. This is the answer.